Alright, so hello guys, how you guys doing? This is Mavi Special and I'll be explaining some introduction to physics because everybody knows that we have something called physical quantities. See, this is a physical quantity. Why? Because I can do what? I can actually measure this. I get my point. See, anything that can be measured is called what? Physical quantities. Now let's assume that I write 1, I write 2, I write 3, I write 4, I write 5. I get my point now. And I write 1 seconds, 2 meters, 3 moles, 4 coulombs, and 5 degrees Celsius. What's the difference? The difference is that for the second one, a unit is actually what? Is actually allocated to each of them. But for the first one, a unit is not allocated. So there's no way for me to actually recognize this. But I can do what? I can always I can only recognize this one because what? If I say 1, I feel like, oh, this is 1 seconds, 2 meters, 3 moles, 4 this was like this 4 coulombs, and this was this 5 degrees Celsius. But now let me explain something to you guys. Do you know that if, okay, let's assume that I go to a university right now and I just got to the gate. I was like, okay, I'm looking for John. They'll be asking me, which part of John are you looking for? I feel like, okay, I'm looking for John. They feel like, did the person have a surname? That means a surname represents what? A unit. That is why you can see I can write 1 1 1. See, I can actually make everything to be 1. Can you guys get me? See, I can actually make everything to be 1. That means everyone can also be what? Can also be John. That means a unit must be what? Must be allocated to each person for them to what? That means every physical quantity must have what? Must have a unit. That is why if you are John, you must have a surname. I am John Oluwasegun. I am John Clement. I am John anything John. That means what? A unit must actually what? Recognize. That is why a unit is a qualifier of physical quantities. Why physical quantities are what? Are quantities that can actually be measured. Now we now have two aspects of physical quantities. We have the fundamental quantities and we have the what? And we have the derived quantities. Are you getting my point? The word fundamental quantities means that something that is there, like something that like exists on its own, something that is natural. Mass is natural. Do you know why that natural? Because what? I don't need to add something up for me to make up of mass. Length is natural. Why? Because what? I don't need to what? Add a lot of length together for me to make a length. Time I don't need to. Why? That's why it's what is MLTI last. This is seven fundamental quantities that we have. Anything apart from this 7, it is derived. Are you getting my point now? That's why it was MLTI what? Lat. MLTI lat. M represents mass, L length, T is time, electric current, luminous intensity, amount of substance, and what? And temperature. That means every fundamental quantities must always have what? Everybody? Fundamental units. Now what is the unit for mass? Everybody know that one. That one is what? It is kilogram, right? For length is what? It is meter, right? For time is what? It is seconds. For electric current is what? Is ampere. For luminous intensity is what? It is candela. For amount of substance is what? Is mole. While temperature is what? It is Kelvin. Kelvin or what? Or Celsius. Now what's the symbol for each of them? Symbol for this is what? Is kg. For this is what? Is m. This one is what? Is seconds. Ampere, right? These are the symbols. This is CD. This one is what? Is N to represent. This one is what? Is degree Celsius or what? Degree what? Kelvin. Are you guys getting me now? Now let's now go into what? Into the derived quantities. Now please, I'll be explaining both dimension analysis with what? With this. I intentionally start from here. Now for derived quantities. I can actually have what? I can actually have a lot of derived. I can actually have what? A lot of things, but I'll just give us 10 from this place. Now I can have area. Area is what? Area is what? Length times breadth. Why is it derived? That means area is being derived from 2 fundamental quantities. See, this length can also be breadth, can also be height. That means I have what? I have length, breadth, and what? Length times breadth is what? Is area, right? That means the unit for meter length is what? Everybody is meter, right? Any size breadth is also what? That's what? That's meter square. I told you, I'll just give you just what? How many examples? Just 10 examples. Now the second aspect of it is that I have what? I have volume, right? Now what is volume? Volume is what? Is length times breadth times what times height. That's what? Meter times meter times meter. That's what? That's meter. How many meter? That's meter what cube. Are you getting my point now? Now let's go to the next one. I can have speed. But what's speed? Speed is what? Distance over time. Distance per unit time. Now anything like distance, everybody know that okay, a car travel 20 kilometer. Meter means what? That's distance. So the unit for distance is what? It is meter. The unit for time is what? It is seconds. That's what? Meter. This x will now go up, and anytime x is going up, it will be what? It will be minus. That x raised by what? Minus 1. Are you getting my point now? Now let's move to what? Let's move to velocity. Now what's velocity? Velocity is what? It is displacement over time. Displacement over time. Displacement over time. That's what? Meter over second. That's what? Meter per second. Yes, you'll be asking me that. Why is it that we have meter per second, meter per second? There's a difference. Now speed is a scalar quantity. Velocity is a vector quantity. Why? Distance is just a separation between 2 points. If I move from point A to point B, that's distance. But if I move from point A going to what's it called? Going to a place with a kilometer, that means whenever a direction is specified, that's without displacement. That means displacement is what? Is a distance covered in a specified direction. While distance is separation between 2 points. Are you guys getting me now? Now I told you guys, I'll just give you what? 5. Just 5 words are derived quantities. Just 10 I mean. Now we have velocity. Now let's go to what? Acceleration. Acceleration is no change. Is no change in velocity. It is increase in velocity, because let's assume that you start your car. It's not the same it's not the same velocity that you will use to accelerate. Like it's not as if now you now want to speed. Immediately you just kick your car. No, it doesn't work like that. That means your velocity needs to be increased. That's why acceleration is what? It is increase in velocity. Increase in what? Increase in velocity over what? Over time. Now everybody, who can tell me the unit for velocity? That's what? Meter per seconds, right? Meter per second over what? Over time is what? Is seconds. And now if I'm having meter per seconds over seconds, that means now I have what? Meter per seconds. This one will also come up. If you guys remember that when this guy was coming up, it is what? Is s minus 1, right? But now we cannot leave it like this, so we need to resolve it. S m raised by what? I'm only someone 1 error. I'm also only someone that 1. That's what? That's minus 2. That's what? Meter per second square. Now we have just 5 more that I'll be giving, guys, so you can be doing the remaining one by yourself. Now let's pick another one. Let's pick force. Now what is force? Force is what? Is mass times what? Acceleration. Mass times acceleration. What's mass, everybody? Mass is what? Mass is kilogram. What's acceleration? Acceleration is what? Is meter per second square. Mass is what? Kilogram. Remember from this place, kilogram, right? Now acceleration is what? Meter per second square. Also the unit of force can also be what? Newton. Why? Because it was given to us by what? By Sir Isaac Newton. Are you getting my point? Are you getting my point now? So that is why you will always see force as 5 Newton, 6 Newton, and so on and so forth, right? Now let's go to another one again. We have something called what? We have something called impulse. What I say now? I call something called impulse. What impulse? Impulse is what? Just force times time. Force times what? Time. Now let's use what's it called? Let's use Newton first, or let's use this. Okay, everybody, what's the unit for force? Force is what? Is kilogram meter per second square. Kilogram meter per second square. Time is what? Times time. Sorry, which is what? Seconds, right? That means I can have what? Kilogram meter. I'm having x raised by minus 2. Do you know that there's always one that is here? And the law of minimum says that if I have a multiplication, it will turn to what? It turns to what? Positive. That's what? Minus 2 plus 1 plus 1. That's what? Kilogram meter per what? Per seconds. Or what is the unit for force? The unit of force is what? Is Newton. That means I can have what? Newton. Time is what? Seconds. That means we have what? We have 7 already. Okay, give me another. Okay, we have something called energy. Energy and work. they have the same what? They have the same formula. Now what's energy? Energy is what? Is force times what? Times distance. Force times distance. Everybody, what is the unit for force? The unit of force is what? Is kilogram meter per second square. Kilogram meter per second square times. Everybody, what is the unit for meter? Meter, sorry, the distance is what? Is meter, right? That means what? I'm having how many meter? I'm having 2 meter. That's going to be what? Kilogram meter square per second square. Or remember, please remember, always remember. Now what's the unit for force? Unit for force is what? It is Newton, right? Out of distance meter. That means I can have what? Kilogram meter square per second square, or what? Or Newton meter. Are you guys getting my point now? So we have how many left? We just have 2 left. Okay, that means I can actually have, okay, this is number 9, right? Hello, can you guys see me very well? Okay, number 9. Now okay, let's have something called prayer. I can have what? I can have prayer. Everybody, what is prayer? Prayer is what? Prayer is what? Force over what? Force over area. Now who can remember the unit for force is what? Is kilogram meter per second square over what? Area is what? Length times, that's what? Remember, the unit for area is what? Is meter square, right? So just come back to this place and just write what? Meter square. Now this m square is going up. That means I have what? Kilogram. There is 1 here before, right? That's 1. If this one is now going up, it will change to what? Minus what? Minus 2. That's why what? Minus 2. That's going to be what? Kilogram 1. Everybody, 1 minus 2 is what? Is minus 1. That's why what? Minus 2. So last but not the least, okay, let's look for one more. Okay, we can have what? Okay, let's do density. But what is density? Density is what? It is mass over what? Over volume, right? Everybody, what is the unit for mass? Mass is what? It is kilogram, and volume is what? It is meter cube. That's going to be what? Kilogram per meter cube. Are you guys getting my point? So now let's move again. Okay, that's all. So I'm giving just what? Just 7 fundamental quantities. Now immediately this 10 derived quantities. Now I'll be explaining dimension analysis. So I'll be going deeper, small. Now let's talk about dimension analysis. Under dimension analysis, you don't need to actually know a lot of stuff. Like, sorry, you need to know a lot of stuff, but at the same time, you need to calm down very well, because this aspect is actually one of the simplest aspects, but students used to have issue with it. I understand. I'm also a student. So now under this dimensional analysis, what you just need to consider is that anytime you see the word mass already represents what? That means do you know that the unit for mass is what? Is kilogram, right? So anywhere you see kilogram is what? Is always what? Capital letter what? Capital letter M. Anywhere you see length, anything length is what? It is meter, right? You always see what? Capital letter what? L. Anywhere you see time is always what? Is always seconds, right? You always see what? Capital letter what? T, right? So anywhere you see what other one? Temperature. Yes, temperature. Everybody know that temperature is what? It is Kelvin, right? Kelvin. So you always see what? K. Capital letter what? Capital letter K. Are you guys getting my point now? Anywhere you see ampere, everybody know that ampere is what? Ampere is electric current. Sorry, like electric current. Okay, we can have what? We can have ampere. And anything ampere is what? It's kind of like what? Current. I. Capital letter I. Now, to actually do this is actually very simple. Now, let's start from the basic. Now, to do the dimension for this guy, do you know that this one is meter square? I told you guys that anywhere you see meter represents what? L. That's what? Length, right? So just come and put what? L square. Now, this is dimension for meter. For area. This is dimension for what? For area. Now, let's check for volume. Volume is what? That is L is power 3. That's L is power 3. Now, if you guys check this one, now we are moving advanced, small and small. Now, let's check for this guy. For this speed. Speed is what? Meter per seconds. Everybody, what is meter? That's also what? L. Everybody, what seconds? Come and check. See, meter is what? Is length. Second is what? Capital letter what? C. For dimension analysis. So we are going to have what? 3 raised power what? minus 1. Are you guys getting my point now? Same thing with this, L3 raised by what? Minus 1. Same thing with this. That's what? That's what? L, right? 3 raised by what? Minus 2. Now for this guy, it's going to be what? Capital letter what? M for kilogram. I told you guys that kilogram is what? Capital letter M. So we have what? We have capital letter M. Meter is what? Is capital letter what? L, and what? S is what? 3 raised by what? Minus 1. So this dimension for what? For this. For energy, you can see that is what? Energy is kilogram meter square per second what? Per second square. So it's going to be what? Kilogram is what? Capital letter what? M, right? This one is what? M square. That's what? L square. This one is second. That's what? 3 raised by what? Minus 2. Are you guys getting my point? So go and do more and look for more formulas. For this guy is what? You can have what? Capital letter M, L raised by what? Minus 1, and 3 raised by what? Minus 2. So for this guy we can have what? Capital letter what? M, L raised by what? Minus 3. So this is the aspects, the introductory parts of what? Of physics. But for JAMB students, I'm going to take a video. I'm going to explain some things to you guys later on. So now I'll be solving some questions related to this part, this introduction parts of the physics.